Alright, today we're going to do something a little bit different. This is a second quiz given in Math 139 at McGill. Well, this isn't just one quiz. This is a combination of all four quizzes. I've made my own worksheet that you can download online at TrevTutor.com in the calculus page. So if you want to do this along with me, it's available for you and is free to download. So we'll sign this off. And class section for our tutoring. It's made to look official, but it's really not. Okay, so this exam has 8 questions. It's a bunch of quizzes from winter 2014's Math 139 at McGill. You can see there's 78 points. A single quiz is probably about half of this. I believe their quizzes were out of 35. I've kept the same point scale. So you can see this one is twice as long, so I'm giving you a little bit more time. If you want a nice letter grade conversion, anything over 70 is going to be an A+, and roughly every 4 marks below that is going to be a letter grade. So you can see that if you don't do too well on this, you might not do too well on a real quiz. Anyways, let's get straight into it. There's a few questions I didn't include, but that was normally because they seem to be out of the scope of Calculus 1 and more with the pre-calculus stuff. So, anyways, question 1. Determine the exact value of each of the following questions. So some of these are limits, some of these are trig, some of these are logs. I figure it's good to give you guys some review with some of this stuff. So we have 1/2 ln 4 plus 2 ln to the 1 over root 2. Well, what we can do is we can raise the constants out front to the exponent. So we're going to have ln 4 to the half plus ln 1 over root 2 squared. So this is going to be ln of 2 plus ln of 1/2. When we have an addition of logs, we multiply. So this is going to be ln of 2 times 1 over 2, which will be equal to ln of 1. And you should know that ln of 1 is 0. So this answer is going to be 0. Let's take the limit as x goes to 0 of e to the 2x plus a cosine of x. This one is fairly straightforward. We just plug 0 into our x's here. So we have e to the 2 times 0 plus cosine of 0, which is going to be e to the 0 plus 1, and e to the 0 is 1, so we have 1 plus 1, and this is going to be 2. C is going to be a little bit trickier. We have the arc sine of 2 pi over 3, and I know you're tempted to write 2 pi over 3 as a result. However, this would be incorrect because the range of arc sine is going to be negative pi over 2 to pi over 2, and 2 pi over 3 is outside of that. So what we really have to do is we have to take the arc sine of whatever sine of 2 pi over 3 is. And you should recall that sine of 2 pi over 3 is root 3 over 2, and then when we take the arc sine of root 3 over 2, we simply get pi over 3. So this is pi over 3. Question D, we're going to take the limit as x goes to infinity of a bunch of this stuff. We're going to use a very, very good shortcut method. And essentially, we're going to try to extract the highest powers out of both the numerator and the denominator here. So we have an x cubed in the second bracket and an x in the first bracket, except we should note it is a negative x. So we're going to get the limit as x goes to infinity. I'm going to say roughly negative x to the 4 over, we have a x squared here and a 2x squared down here, so this will be 2x to the 4. When we cancel our x to the 4s, we will have the limit as x goes to infinity of negative 1 over 2, which we know is just negative 1 over 2. You could expand this and show a lot more work and divide by x to the 4 on top and bottom, but this shortcut is valid, and most profs will teach it to you, and it's a lot quicker and makes a lot more sense. At least when you understand why it makes sense, it makes a lot more sense. So, don't do any more work than you need to. That is my philosophy. Okay, the limit as x goes to 1 of 1 plus ln x over x minus 2. You can see here that they really don't want you to do anything algebraic with these. They just want you to kind of plug the numbers in. So we're going to get 1 plus ln of 1 over 1 minus 2, which is going to be 1 on top, because remember that ln of 1 is equal to 0. And this is over negative 1. So this is just going to be negative 1. Question F is a question I like because it uses a property which says that ln to the e of x is the same thing as x. So what we do is we do it on the first branch here. So we're going to get ln of, well, this ln and this small e will cancel, so we'll get e to the 10, and then we're going to do it again, and this ln and this e will cancel, and we'll get 10. So that answer is 10. Question G is another easy one. Well, sort of. You'll see in a second here where you might get tripped up. If the limit as x goes to 1 from the left of our function is equal to 3, then what is the limit as x goes to 1 from the left of our function over x minus 1? Now, because we have a 1 going in there, you might think 1 minus 1 equals 0. What do? Well, the key is that this is 1 from the left, so it's a little bit smaller than 1. So we have, well, f of x is equal to 3, so we're going to have 3 over 1 from the left minus 1, which is really the same thing as saying 3 over 0 from a little bit to the left. So we can kind of think of this as negative 0.00, so many zeros, and then a 1, which we know tends to negative infinity. So this would be your answer for G. And that was question 1, and that was out of 14 points. Hopefully you could score 14 on this, because I do feel these questions are pretty straightforward. The only one that you might have had troubles with if you haven't done a Calc with Pre-Calc course is this arc sine question. But hopefully you got that and remembered what was going on there. Question 2. These are interesting word problems, and they're not too bad if you can figure out exactly what's going on. So, we have to produce a formula for each of these questions. In the first one, Mr. McGill goes to the bank and makes an initial deposit of $5,000. Let's note that. The bank offers a compound interest at the rate of 2% per year, which means that Mr. McGill's savings at the end of each year will be 102%. Where I would say that this line actually makes the question a lot easier, and I'm not sure why it was included, but I guess McGill thought that would be a nice thing to include that. So we're going to let t be the number of years after the initial deposit, and our function be the savings at the end of the tth year. So what is the function? Well, first we're going to take our initial starting value, and then we're going to multiply it by the percentage we get per year, so 102%, and we're going to raise it to the power t, since after the second year it would be 5,000 times 102% times another 102%. So we keep going t times. Now, how do we write 102% in decimal form? Well, this is the same thing as 1.02. So we get 5,000 times 1.02 to the t. This is our initial value, and this is our increase per year. Now, these next two questions follow the same sort of pattern. So you want to look at an initial and then a multiplier per year. So we have a sample of radionuclide is going through a radioactive decay. The initial number of atoms is 10 to the 23. Okay, let's start this here. 10 to the 23. We want to multiply it by something. So the half-life is 1 day, which means that the number of atoms at the end of each day is going to be 1/2. So probably want to multiply something by 1/2 here. And t is the number of days. So at the end of each day, it is going to be multiplied by 1/2. So after t days, it is going to be 10 to the 23 times 1/2 raised to the t, much like in the first question, where we have an initial value, and then we have the increase per day, where this increase is actually a halving, but it works the same way. You're increasing by 0.5 times. It's the same thing as saying you're decreasing by a multiple of 2. And this third question again follows the exact same thing. In fact, I would say this is probably exactly the same question, except for going the opposite way. We start with 500 bacteria, and it doubles every half hour. And we let t be the number of hours after the culture starts, because we are dealing with a bacteria culture, and n of t be the population of the bacteria at the end of the tth hour. So what we have here is we have an initial starting at 500, and then we multiply by 2 to the power of t. And when I look at the answer key for this quiz that they gave, and I look at the question here, this is definitely wrong. This should be 2 times t to the 1/2 of t, because this is every half hour. Or it should actually be 2t. I would say for this answer to be 2 to the t, this has to be the bacteria at the end of every tth half hour. Otherwise, the quiz is a little bit wrong because this is doubling every half hour, which is really quadrupling every hour. So either way you look at the question, it wasn't quite worded appropriately to the answer key that they gave. So this would be a better definition of their answer key, and I suppose if it was every half hour, 4 to the t would be sufficient. So out of 9, I don't know, I'd say 6 would be fine. If you didn't know how to do one of the questions, then you pretty much didn't get all of them, so I'm just kind of assuming that you got one wrong, learned how to do it, and then got the rest right. Alright, this is the fun stuff, because now we get to continuity. So we assume there's 2 numbers that we don't know in the reals, and we have a function, and we want to determine the values of a and b, such that the function is continuous at 1. So, what does it mean to be continuous at 1? This means that the limit as x goes to 1 of f of x is equal to f of 1. Well, first let's determine f of 1, and this is equal to a. Because if x is equal to 1, we get a. Let's take the limit as x goes to 1 from the right, so we're going to deal with e to the x minus 1, which is going to be e to the 1 minus 1, which is e to the 0, which is equal to 1. Okay, so the limit as x goes to the right is equal to 1. What is the limit as x goes from 1 to the left? Well, this is negative x squared plus b, which is going to be negative 1 plus b. Okay, so what we want is we want the limit and the function at 1 to equal to each other. So we want a equal to 1 equal to b minus 1. So from here, if we let a equal to 1, we want a equal to 1, and then we want 1 equal to b minus 1, which we can see that b is equal to 2. That was not too bad. So now what we have to do is we have to sketch this bad boy, and I will remind you that a is equal to 1 when x is equal to 1. We have e to the x minus 1 if it is greater than 1, and we have negative x squared plus b when x is less than 1. And of course, I should write a is equal to 1 and b is equal to 2. So now we should draw this. Well, okay, if x is equal to 1, then a is equal to 1, so we're going to have a point at 1, 1 here. Then when x is less than 1, we have a parabola that is going to be, well, let's plug x equals 0 in, and we'll figure out where the tip of the parabola is, which is 2. So this is going to be the tip of the parabola, which is going to be 0 and 2. And if we know how parabolas look, we know they are going to look like this. It's going to be facing downwards, and it's going to follow a nice pattern and cross somewhere here, which doesn't have to be labeled, but should be between -1 and -2. Now we graph the right side, which is e to the x minus 1, and we don't really have to put in any values here because we know that e to the x grows really fast, so it is going to look like this. And this would be a nice graph. So I can't give a nice point evaluation on this because if you did not get the first value, then you're sure not going to get the second one. So I'm assuming the average here is probably like, I don't know. If you got the first part wrong, you'd get 3 out of 12. If you got the second part, or if you got the first part right, you'd probably get a little bit over 10 out of 12. We're going to do the same question, except instead of finding values where something is continuous, we are going to check to see if it is continuous or not. The first thing I have to mention is that in the top function, we have an absolute value. And we have an absolute value of x minus 1. So we know the absolute value of x minus 1 is going to equal x minus 1 if x is greater than 1, and it's going to be 1 minus x if x is less than 1. But here we're saying x is greater than 1, so we're going to rewrite our function to be 3 minus x times x minus 1 over x minus 1 if x is greater than 1, and we'll have e to the x minus 1 plus 2 for x less than or equal to 1. We do get some nice cancellation up top, so we will just simplify this to say the top is 3 minus x. Now we want to know if it is continuous at 1 or not. So we'll check to see if the limits as x goes from the right is equal to the limit as x goes to 1 from the left. So from the right we have 3 minus x, which is 3 minus 1, which is 2. And from the left here, we're going to have e to the x minus 1 plus 2, which is e to the 1 minus 1 plus 2, which is e to the 0 plus 2. And we know that e to the 0 is equal to 1, so the limit from the left is going to be 3. And, well, you can see that these limits do not equal each other. Therefore, the limit does not exist at x equals 1. Therefore, it is not going to be continuous. So now we have to sketch this graph. which might be a little bit challenging, but we know that it is 3 minus x for x greater than 1, and it is e to the x minus 1 plus 2 for x less than or equal to 1. So let's evaluate both functions at 1. So from the right, we have 3 minus 1. Well, we know 3 minus 1 is equal to 2 because we have the answers up here. So this is going to be the start of the function 3 minus x, which we know is just a very nice graph that looks like this. Probably learned this in high school. And e to the x minus 1 plus 2, well, we know at 1 it's going to be at 3 here. And if we know anything about e to the x, at negative infinity, it never quite reaches 0. So it's never going to quite reach 0 plus 2. So we have this horizontal asymptote here that it's never quite going to touch. So it looks a little bit like this. And this would be your graph. This one I would say is a little bit harder, but you should be aiming for at least 10 out of 12 on this. And of course you're thinking, how do I get 10 out of 12? Well, you'd probably make some error either with this horizontal asymptote, or you might get this point wrong. Now we have to evaluate a limit. This was probably the hardest question on any of the quizzes, and only because it's very mechanical. So when we have square roots, what we need to do is we need to multiply by the conjugate. So I will write this whole thing out as a multiple of the conjugate. Actually, I'm going to be just a little bit lazy and write it out on the side here. So we have the same term, 3x squared plus 4x plus 5, and because we subtracted here, we are going to add in our multiplication. And this will be 3x squared plus 2x plus 1, and of course this will be multiplied by the same thing, which, for simplicity's sake, I am not going to write out the bottom part until I need it. So I will explicitly say here we're working with the numerator. So when we multiply out the numerator, we are going to get 3x squared plus 4x plus 5 minus 3x squared plus 2x plus 1. It's really convenient how this works when you multiply by a conjugate, which is going to be, well, the 3x squares will cancel. A 4x minus 2x is going to lead to 2x, and a 5 minus 1 is going to lead to 4. So we're going to have 2x plus 4, and now we will include our limits and our denominator. We have 3x squared plus 4x plus 5 plus the square root of 3x squared plus 2x plus 1. At this point, what you could do is you could multiply or divide the bottom by root of square 2, or the root of x squared, and divide the top by x, and continue from there. But I'm going to teach you yet another shortcut and use one, where we are going to take the highest powers in the top and the bottom and just work with those. So we're going to take the limit as x goes to negative infinity of 2x over the square root of 3x squared plus the square root of 3x squared. So this isn't too bad. Now what we'll do is we'll take the limit as x goes to negative infinity of 2x over root 3x plus root 3x, which is going to be, as we take the limit negative infinity, the top is going to end up being a negative number. Well, actually, I should say this first. We cancel out these x's, so we get 2 over root 3 plus root 3, which is 2 over 2 times root 3, which is 2 over root 12. Well, we won't even do that part. Instead, what we would do is we would simply simplify the top and bottom. So we have 1 over root 3. What we do here now is we plug in our negative infinity to these guys here to check to see what sign we would get. So we know the top is going to be negative, and the bottom, because we have to square it, is going to be a positive plus a positive. So we're going to get a negative infinity over an infinity, which gives us a negative sign, which means that this answer here should be negative. So we get negative 1 over root 3. Of course, you could do this the long way, but just looking at the highest powers in the denominator and the numerator will give you the same result and is much faster when writing an exam. These last two questions are pretty much the same, and these are intermediate value theorem problems. We want to show that sine x is equal to x squared minus x minus 1 has at least one root in the interval 0 and 3. So we want to take our f of x and put everything on one side of the equation, so we get x squared minus x minus 1 minus sine of x. We now evaluate f of 0, one end of the interval, so we have 0 minus 1 minus sine of 0, which is going to be negative 1. And now we're going to take f of 3, which is going to be 3 squared minus 3 minus 1 minus sine of 3, which is going to be 9 minus 3, which is 6, minus 1 is 5, minus sine of 3. So what's interesting here is that we know that sine of x is going to be between negative 1 and 1. So this means that the lowest value 5 minus sine 3 can have is going to be 4. And because f of 0 is less than 0, which is less than f of 3, in fact I should write this, negative 1 is less than 0, which is less than 4, which translates to this second line, we know there exists a number within 0 and 3 where f of c is equal to 0, which means that there is a root there. We don't know where it is, but we just had to show that there was at least one root in the interval. So hopefully that wasn't too bad, and of course you should remember the intermediate value theorem. This is a very important theorem which is used to show a lot of things in analysis, so you should probably learn this and memorize it. Question 7 is pretty much the same thing here. We want to show that the following equation has at least one positive root. So what this means is that we have the interval 0 and infinity. So we'll do the same thing. We'll set up a function f of x. It's going to be equal to 3 minus 2x minus e to the x. We'll first check f of 0, which will be 3 minus 2 times 0 minus e to the 0, which is going to be 3 minus 1, which is 2. And now we want to find a value that is going to be less than 0. So we know that e to the x is going to grow very quick, and we're subtracting it. So we have some very nice numbers we could pick here. But just for safety, let's pick f of 10. It's a little bit large, but we're not given a specific interval we have to check. So if you wanted, you could check f of 10 million, but that is going to be overkill, and I'm already overkilling it enough. So we have 3 minus 2 times 10, minus e to the 10, which is going to be negative 17 minus e to the 10, and this is some ridiculously large number, so we know this is going to be negative. In fact, we'll just write negative. So here we find that f of 0 is going to be greater than 0, and f of 10 is going to be less than 0, so we know there exists a number in 0 through 10 where f of c is equal to 0. Therefore, it has a positive root. So those were the questions I thought were really good from Quiz 2 in Math 139 at McGill. I won't be doing Quiz 1 because Quiz 1 was basically all of pre-calculus. So hopefully, if we take a look at what you could have got here, 6 for the second question. For the third question, hopefully you got 10. The fourth was 10. The fifth question, probably you made a mechanical error somewhere. Really, I'd say 6 is good, because you would get the conjugate right, but then perhaps you got problems with the sign on the limit. And hopefully the last questions, you got at least 7 on those. So I would say if you're a good student and you've been studying well, you should be able to get this score, which is 46.53, which is about 60. So this translates to a B+. If you think that my recommendations were a little bit too high, perhaps you need to study more, because a B+, although it's still hard to get, it is not a grade you should be aiming for. So try to get those marks. Key parts to this question, or to this exam, I will write down here because it is quite important. Obviously you want limits, you want to be able to plug in numbers and to solve algebraically. Of course you also want some limits at infinity, which were tested here. You want the intermediate value theorem, which was very important. You want to be able to have growth and decay questions, which I will admit these are pre-calculus, but hopefully you remembered some of them. And that was pretty much what was tested in this quiz. Quiz 3 will do derivatives. I already have that up on the website if you want to check it out. So hopefully you've enjoyed this. If you have tests, exams, quizzes from your own classes, feel free to send them to contact@TrevTutor.com, and I will make as many videos as is necessary to have a nice collection of exams and stuff on the website.